Okay, page 5. Now we're going to be working with the line of best fit. Calculate the mean point of the distribution represented by the symbols x bar and y bar. X bar would be the mean x coordinate and y bar would be the mean y coordinate of the distribution. Mark that point on the scatter diagram. Step 3, draw the line of best fit through the point with about the same number of points above the line as below it. So, in the days before computers, this was the procedure to try to find an equation that would fit your data. For each of the following data sets, draw the scatter diagram and draw a line of best fit incorporating the mean point. Find the equation of the line you have drawn. Okay, so let's look at A here. To find the mean here, we could use the calculator. And I'm just going to go ahead and show you how you use stat edit to do this, because we're going to do that anyway. No reason to suffer. Gonna clear out my data here. Okay, and I'm going to put the x data here on the left, 1, 2, 3, 4, 5, 6, 8, or 1, 3, 4, 5, 6, 8, and my y data I'm going to put in L2, 2, 3, 3, 4, 5, 7. So 1, as you can see, I have put my data in here, 1, 3, 4, 5, 6, 8, 2, 3, 3, 4, 5, 7. So the L1 are the x coordinates and L2 are the corresponding y coordinates. To find the x bar and y bar values, the mean x coordinate, the mean y coordinate, I do stat calc 2-var stats because I have two variables, the x variable and the y variable. L1 goes into x list, L2 goes into y list, and then I do calculate. And it gives me for x bar 4.5. And for y bar, I just need to go a little bit farther down. And there it is, y bar is equal to 4. Okay, so I am going to put this graph here. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my first point is 1, 2. Second point is 3, 3. Third point is 4, 3. Next point is 5, 4. Then 6, 5. And 8, 7. 8, 7. There we go. And then I'm going to mark my mean point at 4.5, 4. Right there. Right? And then I'm going to draw my best fit line. And the best fit line is a straight line which goes through the mean point, which is blue here, and it's going to have about the same number of red points above it as below it, and that's my guess. Okay? Now, what do I do with this? I am going to find the equation of this line, and we can't use the calculator to do this because this is a sketch, right? So what I'm going to do is I'm going to try to estimate the slope here by trying to find some points which are almost whole numbers. So I'm going to do the slope between these 2 points here, which happen to be whole numbers. So let's see, the rise here appears to be 1, 2, 3, 4, 5 blocks tall, and the run appears to be 8 blocks wide, right? So the slope appears to be positive 5 over positive 8. The y-intercept, on the other hand, appears to be 1.2 about. Okay, so our line, they tell us to find the equation of the line. The line would be y equals m, which is 5/8 x, plus 1.2 approximately. Okay? So all these here, B and C, are similar. What you're going to do is you're going to plot the data, then you're going to sketch a line going through the X bar, Y bar point, and then you're going to estimate using like a slope triangle like this, the slope, and then you're going to see where the y-intercept is, and based on that you're going to write an equation like that for B and for C. Okay? I'm just going to start you off with the scatter graph for each one, just so that you can kind of see how to divide up the screen. For this one, B, looks like the smallest value for X is 1. The largest value appears to be 18. For Y, the smallest value appears to be 5, and the largest value appears to be 18 also. So for B, I'm going to put, I think 0 through 20 for the points, and of course 10 in the middle. And then same thing for the Y's. Put 20 here, and put 10 here. So the first point, for example, is 13, 10. 13, 10 would be here. Next point is 18, 6. 18, 6 would be, 18, 6 would be here. 18, 6. Okay? And then 7, 17 would be here. 7, 17. It would be about there. I'm sorry, here. 17. And 1, 18 would be about here. And 12, 13 would be about here. And 6, 14 would be about here. 15, 6 would be about here. And 4, 15 here. 17, 5. Go. And 3, 14. There we go. And then we'll use the calculator with StatEd to figure out our X bar and Y bar. And then we'll draw our line through there and estimate the slope. Okay? So just do the same procedure we did in A. Number 3. To investigate whether speed cameras have an impact on road safety, data was collected from several cities. The number of speed cameras in operation was recorded for each city, as well as the number of accidents over a 7-day period. Okay, so we have X is the number of speed cameras, and Y is the number of accidents. Construct a scatter diagram to display the data. Calculate R for the data. Describe the relationship between the number of speed cameras and the number of car accidents. Plot the mean point on the scatter diagram. Draw a line of best fit through the mean point. And where does your line cut the y-axis? Interpret what this answer means. Okay, so we're going to do a combination of what we did on the previous page, where we calculated R, and we're also going to draw a line of best fit. Okay, so let's look at our data. Looks like the smallest number here is a 3. The biggest number here in the x's looks like 28. And then for the y's, the biggest number appears to be 48. And the smallest number appears to be 19. Okay, so let's try to divide up our axes here. So 28. So I would say 28. So that would be 10, 20, 30. Okay, for the x's. And then for the y's, go all the way up to 50. 50, 10, 20, 30, 40, 50. Okay, so let's do our points here. 7, 48 would be about here. 15, 35 about here. 20, 31 about there. 3, 52 here. I didn't realize 52 is higher than 50. I missed that one. 16, 40 here. 17, 35 here. 28, 28 there. 17, 30. There we go. 24, 34 out there. 25, 19 here. 20, 29 here. 5, 42 out there. 16, 31 out there. 25, 21 there. 15, 37 there. 19, 32 here. Okay, so we constructed a scatter diagram. It says calculate R for the data. Obviously, we're going to use a calculator to do this because that's a lot of numbers to try to do that by hand. Okay, so we're going to clear our data here, and then we're going to type in all these X and Y values. So the X values and the Y values we're going to put in these two columns. So we'll start it off, we'll put 7 in, then 15, then 20. And I'll do this offline so that you don't have to watch me do all this. Okay, so I have all my data now in stat edit. And then to find the R value, I'm going to do statcalc linreg. And remember, I have diagnostic on. And so I can see that R is negative 0.878. Okay. Describe the relationship between the number of speed cameras and the number of car accidents. Okay, we could say that there is a linear correlation. And the linear correlation is going to be negative. And it looks pretty strong. 0.878 is very close to 1. Let's go back and look at the page where we figured that out. So 0.878 would be pretty close to, it would be strong because look, it's a little bit above 0.87, right? Or it's between negative 0.95 and negative 0.87. So we would say strong negative. Oops. Strong. Okay. Plot the mean point x bar y bar on the scatter diagram. Our mean point we can find by doing stat calc and 2-var stats. Remember that from the last problem? We specify list 1 and list 2, and then we do calculate. And the x bar value is 17. 17. And the y bar value, we have to go to the second screen. There it is, 34. Okay, so I'm going to mark x bar y bar with a blue mark. 17, 34. It's about there. Okay, and then I'm going to draw a pink line going through that blue point and also going right through the middle of the cloud here. Okay, so there's my best fit line. Where does your line cut the y-axis? Interpret what this answer means. It looks like it's at about 47. So it cuts it at 47. Let's remember, what is the meaning of each of these axes? The first axis is number of speed cameras. The x-axis is number of speed cameras. And the y-axis is the number of car accidents. So 47 is the number of car accidents, number of car accidents with, or in a city with no speed cameras. Okay, so if you have no speed cameras, you would have 47 car accidents. And if you have an increased number, then you would have less car accidents. And it says to draw a line of best fit, but it never tells you to find the equation of the line of the best fit, so we don't need to do that. Okay? So that's it for this page.